Today we are uncovering statistical test. Which test exactly do you have to apply in any given scenario on the exam? So, to begin with, imagine that you are a very brave scientist and you're trying to figure out a difference between two groups. Let's say you're trying to hunt down the difference in caffeine level between coffee drinkers and tea sippers. So, you take 5 participants who drink tea and 5 participants who drink coffee and you measure their sample caffeine levels. And then you go ahead and take the mean of these values. So mean would be like taking the average of these values. Now I want to compare. I got the average level for tea drinkers to be around 3 and for coffee to be around 4. Now I want to figure out if the difference that I'm seeing is actually statistically significant or not. Now this is an ideal situation where you can use a t-test. So this is a t-test showdown. So basically you have to establish statistical supremacy. How do we do that? So I'm just mentioning this for completeness sake, but we calculate something known as the t-value. Once you have calculated the t-value and it is big and it is towering over the critical value, if the t-value is greater than the critical value, you'll not be asked to do this on the exam. This is just for completeness sake, that all you have to know is that what is the situation in which you will have to apply a t-test. So when you are comparing means of two different groups, in order to compare the means of two different groups, you would use a t-test. So what we do is calculate the t-value, and if it is greater than the critical value, you have got a statistically significant result. And we know that whenever the result is statistically significant, we tend to reject the null hypothesis. Null hypothesis is the hypothesis that states that there is no real difference between the two groups, between the means of the two groups. So we reject the null hypothesis in this situation because the t-value is greater than the critical value. So now there are two main types of t-test. There is an independent t-test and there is a paired t-test. The independent t-test is used when you have got two separate groups. As you can see, I've demonstrated it with different colors. So when we are dealing with two different groups that are not related to each other, like our tea group and our coffee group, that is an independent type of t-test. Then there is something known as the paired samples t-test. Now paired t-test can be used when you have got just one group of participants. Like here you had two groups of participants, right? This was one and this is another one. And you're comparing the means. Paired t-test would be when I take just one group of individuals and I test them under different conditions. So one group of participants is being measured twice under different conditions. Like before receiving treatment with warfarin, I'm measuring the mean INR. And let's say that same group, I switch them after washout period of a week or so. I switch them over to heparin. And then I'm measuring again the mean INR value. Now because the group of individuals remained the same, just the testing condition changed. This would be an example of paired t-test. Now, if let's say I'm like, okay, I measured the mean or average caffeine level in tea drinkers and the average in coffee drinkers, and I want to add another category here. Let's say, what is the average caffeine level in Red Bull drinkers and how does it compare to the coffee and the tea drinkers? So whenever we want to compare the means of more than two groups, so more than two group means, if you have to compare, then we use something known as the ANOVA test, analysis of variance test. It's that simple. When you're comparing means of two different groups, we use the t-test. We talked about independent and paired. And if you want to do more than two groups, then you use the ANOVA test. Now chi-square test, we'll be going over what would be an ideal situation where you would choose a chi-square test. So for the magic of chi-square test to work, Let's take an example. Imagine you are on a quest to figure out if there is any connection between breathing fire or smoke breathing dragon and a fresh air enthusiast. So picture this. You're hanging out with the dragons, some of them are breathing fire, some are not. Then you've got your male dragons and you've got your female dragons. And you're wondering, hey, is there some mystical link between gender and the smoke habits? And you start counting. There are 6 dragons who are male and they breathe fire. There are 4 male dragons who are just 4 male dragons here who are just enjoying the fresh air. Then we have got 4 very fiery female dragons breathing fire, and then there are 6 female dragons who are keeping it absolutely smoke free. So this is the ideal situation where a chi-square magic would happen. You toss all these numbers into a contingency table, into a 2 by 2 table like we have done in this situation, right? And you will get the value. So all you have to know is what would be the situation where you'll be like, oh, chi-square test. So just notice that here we did not talk about any mean or average. We talked about proportion. We talk about percentages for chi-square test. So I'd be like, okay, 6 out of 20 dragons, 4 out of the 20 dragons, and then so on. So when we are comparing proportions or when we are comparing percentages, we use the chi-square test, and you can just think of it like if you can throw the values that they have given to you in a question in a contingency table, you can apply the chi-square test to that. So finally, which test to use depends on the variables that you want to compare. If you're comparing means, are those independent sample means? If they're independent samples and there are 2 groups that you want to compare, we use the 2 sample t-test, also known as the student's t-test. When we want to compare independent samples between more than 2 groups, we use the ANOVA. When for the mean the same individual is followed over time, tested under different conditions, followed over time, you use something known as the paired t-test. It's paired. You're just following the same group of individual over time under different conditions. Then when we are comparing proportions like 2 out of 10 or percentages, that would be like 20%. So when we are comparing proportion or percentages and your sample size is big, we use a chi-square test. And when we are comparing small sample sizes, proportions or percentages, and the sample size is like really small, you can use something known as the Fisher's exact test. So remember, brave statisticians, just embrace the thrill of statistical adventures, and may the p-value always be in your favor.